That says everything but 4. Here's another way to say anything but 4. Anything but 4. There's another way to say anything but 4. In fact, it's exactly a way to say anything but 4. That says the same thing. Anything but 4. Here's another way to say anything but 4. Right? The old open circle concept. Hey, look at there. I'm coloring in every single thing, every single point except 4. That also says any real number except 4. I know we have been using parentheses, but when you do parentheses, it kind of gets a little confusing. So I use the open circle. So you know what the domain is, right? It's anything but 4. And you know a strategy to find the domain when you have a fraction. Set the denominator equal to 0 and solve. Check this guy out. Now, some of you can look at that and solve and find out what x cannot be. Most of us will have to actually go through the strategy steps of taking the denominator, setting it equal to 0, and solving. Subtract 5. Divide by whatever's in front of x. In this case, 7. X is negative 5, 7. Keep in mind what you just found. What have you just found with this?
What it can't be.
Domain is everything but this, or you've just found what x cannot be, right? X cannot be that because that's the one value in the entire universe that makes the denominator 0, which is not acceptable. So my domain, set of all x such that x is a real number and x is not equal to negative 5 seconds. Or it's anything but negative 5 seconds. Maybe you want to express it. So far, so good? All right, try this. I want to know what the domain is. Remember, the domain is all real numbers unless one of these limitations applies. And it looks like number 1 may apply. No value is allowed in the domain that causes the denominator to be 0. So here's the question you're going to have to deal with. Is there some x that causes this denominator to be 0? Yes or no? Question. Is there some value that causes that denominator to be 0? That's kind of the first step to get over before you start finding out what the x is. Is there an x that causes the denominator to be 0?
No.
Why did you say no? I'm all ears.
Because you can't square
Oh my goodness, that's right. I would have to square something and get negative 5 to add to 5 to get 0, right? Tell me about x squared if x is a real number. Any real number. Square it. What do you get? Positive number. Except for 0. But you square any negative, you're going to get a positive. Square any positive, you're going to get a positive. The only thing that's not negative or positive is 0. Square 0, you get 0. What's the smallest that x squared can ever be if x is a real number?
1.
Be careful. The smallest.
1.
What's the smallest x squared could ever be if x is a real number?
1.
I just said it. 43 seconds ago. 0. 0 is a real number, ladies and gentlemen. 0 is a wonderful real number. You square 0, you get 0. That's the smallest you can ever get, right? Because if you square a negative, that's going to be a positive number. That's bigger than 0. And if you square a positive, you're going to get a positive number, which is bigger. The smallest this could ever be is 0. So, what's the smallest this could ever be? 5. That can never be 0, ladies and gentlemen. The smallest that denominator can be is 5. So let me ask the question again. Is there a value of x that causes the denominator to be 0?
No.
No. So when I ask for the domain for this guy, what is the domain? All real numbers. Remember, the domain is always all real numbers unless one of these limitations applies. Hey, get that? Did you understand that concept? Just because you got an x in the denominator doesn't mean there's going to be a limitation on the domain. You got to ask the question. Is there a value of x that causes this denominator to be 0? And if you went through the strategy, x squared plus 5 equals 0, x squared equals negative 5, x equals the square root of negative 5, put that in your calculator, and it's going to say, sorry, no real number like that. All right. None of that I stuff yet. That's for next chapters.
So then can you pretty much assume anytime you see an x squared in the bottom that that's going to be the case, right?
Pretty much. Pretty much. If I snuck in a negative sign in front of the x squared, that could be a problem.
But
If it's just plain old x squared, you're right. The x squared says the smallest this can be, real number-wise, is 0. So if you got something added to it, it's never going to be 0. All right. That's the first limitation. It says you got a fraction, but the denominator could possibly be 0 based on one of your x choices. You eliminate that value from the domain. Here's the second thing that your calculator objects to. And that's when I put the square root of a negative number. My calculator equally says error. Okay? And notice how it's defined because it's very precise. No value is allowed in the domain that results in a negative number under a radical with an even index, like a square root, a fourth root, a sixth root, a seventh. All right, let's ask the question. Can you think of an x value that would cause that radicand, the thing under the radical, to be negative? Can you think of one? Anybody think of one?
If x is negative 5.
What could x be that would make it negative?
Negative 5.
Negative 5? Okay, let's see. 3 times negative 5 is negative 15. Plus 5 is negative 8. Yep, that's a problem. Square root of negative 10. But here's the thing, ladies and gentlemen. If you can think of one value of x that makes this problematic, that implies there's an infinite number of x's that make this thing problematic. Hey, negative 100 makes it problematic, right? Negative 100.7 makes it problematic, right? All those negative numbers that you just thought of make it problematic. So I need to know what values make this problematic. Let's see. Here's my strategy. Take the radicand, that's the thing under the radical, right? In this case, 3x plus 5. And set it greater than or equal to 0.